All right, so 5-3 discussed two different things. Bisectors and triangles. Now, we've already looked at perpendicular bisectors and angle bisectors. So we know that a perpendicular bisector bisects the side that it cuts and is perpendicular to that side. We know that an angle bisector bisects the angle that it's coming from, the vertex of that triangle. But if you have all three perpendicular bisectors in the triangle and all three angle bisectors in the triangle, they intersect in a particular point, and their intersections create certain things, which we will explore here in a minute. But for right now, I want you to answer questions 1 through 3. Have a review to see if you remember. So what do you think about number 1 is, and it's important that you know which is a perpendicular bisector and what's being cut. So there's a knife and there's the thing that's being cut. The knife is the perpendicular bisector. So number 1, segment AB is the perpendicular bisector of segment CB. True or false? I heard one answer. True or false? It is false. Why? It is flip-flop. This is the median of AB, and AB is the one that's been cut in half. So AB cannot be the knife. It cannot be the bisector. So CD must be the bisector. So that means that 2 is true. CD is the perpendicular bisector, so it intersects segment AB at its midpoint. So that's the true statement. Is there a late bus? Or are y'all just late today?
We're just late today.
Oh, okay. There's like 5 of you today. All right. Brenna, shh. Will you grab one of those? All right. So question 3. Question 3. Any point on segment CD, mind you, segment CD is the perpendicular bisector, is equidistant from points A and B. True or false?
True.
Any point along here. Brody, why is that true?
Because it's right in the middle and it's...
Well, the perpendicular bisector theorem says so, right? The perpendicular bisector theorem says that any point on the perpendicular bisector will be equal distance from the endpoints of the segment that it bisects. So any point here, so I could put a point here and it would be equal distance. I could put a point here and it would be equal distance. So that is true. Then we're going to use this word today, concurrent, and really the main thing that you need to know. What? This is not made up. It's not made up.
It sounds made up.
Well, because it's not a normal word that you might use in everyday life. Okay, then I wasn't going to do this, but then we're going to do 4, 5, and 6.
Okay.
No, we're going to do it now. All right, so the math usage for concurrence, this is just an increase in your vocabulary. You can use this in English class. When 3 or more lines intersect in one point, they are concurrent. When 3, it has to be 3, not 2. When 3 or more lines intersect in one point, they are concurrent. So you have a picture to the right of that occurring. So then let's look at 4, 5, and 6. You're going to use concurrency, concurrent, or concurrently in those sentences. So put the correct word in the sentence. So to prove that these are not made up words, bless you. 2 classes are concurrent when they meet at the same time. The point of concurrency, here's your math usage, of 3 streets is the intersection of streets. Does anybody know what 3 streets in Arizona meet concurrently?
52nd, 23rd.
No. Some of those are parallel. Anybody experienced Grand Avenue? Really? Y'all need to travel a little bit more often. Grand Avenue is a street that goes diagonal. Have you noticed that all the streets in Phoenix go north-south or east-west? North-south or east-west. Have you noticed that? We live in a grid. But Grand Avenue is diagonal to a lot of streets. Whenever you start to drive, which some of you have started to drive, right? Has anybody gone through driving school? Anybody gone through driving school? Because typically, one of the things in driving school, they'll take you to Grand Avenue and make you take a left turn on around Grand Avenue, because it's very terrifying. No, it's in West Phoenix. That's true. Grand Avenue's not downtown. But anyway, if you ever, one of your driving things that you should have to pass is having to experience Grand Avenue. There is concurrent streets at Grand Avenue. There are 3 or more streets intersecting. Trying to make a left turn is quite terrifying if you're not used to it. Just saying. So tell your parents, Miss Murray said you need to take me out down Grand Avenue. And some of your parents are going to go, I'm not going there. Okay, so look at the diagrams below, and I want you to determine, number 7, are those lines concurrent or non-concurrent? They are concurrent. What about number 8? These are non-concurrent. They're just intersecting. What about number 9? Definitely non-concurrent. Non-current? Oh, that's funny. How about non-concurrent? I knew it looked a little funny. All right, so flip. So here comes the meat of the matter, so to speak. So here's a new theorem for your flashcards. This should go on your flashcard along with this picture. The perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. Very important. At a point equidistant from the vertices. So this is the concurrent point right here at point P. Everybody's looking? So here you have the 3 perpendicular bisectors of the triangle. They have not been drawn all the way. They've only been drawn to the points of concurrency, right? So these right here are your perpendicular bisectors. They've cut them off at the points of concurrency. This distance here is what they're telling you. When this happens, this distance, and this distance, not the part of the perpendicular bisectors, but the distance that this point P, the point of concurrency, is from each of the vertices is equidistant. So we can use that to help us solve things in triangles. Now, number 10 is saying mark and show all the congruent segments. So I marked these as congruent from the point of concurrency, but because we have perpendicular bisectors, aren't these pieces congruent? And aren't these pieces here congruent? And aren't these pieces here? Then you have tick marks. Congruent. I can't say that these pieces are all congruent to each other, but they're congruent to each of the pieces next to it. They have a lot of congruent pieces within that triangle based upon those perpendicular bisectors. They do a lot. All right, so look at problem 1. What are the coordinates of the circumcenter? Well, what the heck is the circumcenter? That is your point of concurrency. So you might want to write up here. The circumcenter is the point of concurrency. So P is called the circumcenter of the triangle. So if they tell you that, you know that it was created from 3 perpendicular bisectors. So we want to know what's the coordinate for the circumcenter of the triangle with vertices, and they give you those. So we're going to plot those. So plot 2, 7. And name it point A. Plot 10, 7. And name it point B. And plot 10, 3. And name it point C. And then we're going to connect the dots. You thought you got rid of connecting the dots in kindergarten. So here's our triangle. So we drew number 11, we drew the triangle on the coordinate plane, we labeled the coordinate, we want to label the coordinates of the midpoints. So we're just going to go ahead and give those whatever letters we feel like. So find the midpoint from A to B. How far is A to B? What's the distance? What's the distance from A to B? 8. So halfway would be 4. So right here, I'm going to call this point D is the midpoint. So this piece is equal to this piece. And if I were to draw a perpendicular bisector, it's easy on this picture to draw it, wouldn't it go through here? Then we're going to find the midpoint from B to C. So how far is it from B to C? 4. So the midpoint would be at 2 units. So right here, we're going to call this point E for Edward. So these 2 pieces are equal to those 2 pieces. And then let's draw the perpendicular bisector, which would be easy for here. And note that both of those perpendicular bisectors intersect the hypotenuse AC at this point here. Well, we're going to call that point F. Fabulous. Is F the midpoint of A to C? How could I tell for sure? I could find the distance, but there's an easier way for us just to identify. Didn't I create a right triangle here and a right triangle here with those perpendicular bisectors? Can't I find the slope from A to F? And if the slope from A to F is the same as the slope from F to C, in other words, exactly the same distance from here to here as from here to here, won't the triangles be congruent? So if I can prove that this is congruent and this is congruent and they both have right angles, the triangles are congruent by SAS. So isn't this distance 2 and this distance 4? Isn't that distance 2 and that distance 4? And I have right angles. So I know for certain that those pieces are congruent. So the perpendicular bisector for F would appear to go, well, if F's slope is positive 2, negative 4, isn't that negative 1/2? What's the perpendicular slope to negative 1/2? Positive 2 over 1. So we're going to go up 2 over 1, or down 2 over 1. Here I've created the perpendicular bisector through F, and the point of concurrency is this point right here. It happens to be on the triangle. So the circumcenter is not necessarily always in the center of the triangle, is it? What that tells you is that if I were to create a line, and we can go ahead and do this, if I were to create a line from B to the circumcenter, and from C to the circumcenter, which would be this portion, and then from A to the circumcenter, which would be this portion. These 3 pieces here, I'm just going to highlight them. This piece here, and this piece here. What do you know about those pieces? Those are the distances from the vertices of the triangle to the circumcenter. They're congruent. So I know that A to F is congruent to B to F is congruent to C to F, just based upon our theorem. What is the point of the circumcenter? What's the ordered pair? 6, 5. So let's go ahead and put that in there. So they could ask you a lot of questions with that, but there's something inside your coordinate grid. Now it was easy to do because it was right triangle and your legs were vertical and horizontal. If your legs were not vertical and horizontal, it becomes a little bit more difficult. You'd have to apply the midpoint formula. And then you'd have to do what I did here and find the perpendicular slope. This one was easier, so we'll see what you end up getting in your textbook. All right, problem 2. Using a circumcenter. A town planner wants to place a bench equidistant from the 3 trees in the park. Well, the 3 trees in the park, if I were to connect the points, make a triangle. So let's go ahead and connect those points. So this town planner remembers his high school geometry, because he wouldn't want anybody to have to go too far to get the bench. Everybody should get to an equal place on the bench. So where should he place the bench? What do you need to do first? What? I'd have to find the length of each side, right? And then do what? Why would I want to find the length of each side of the triangle? So I can find the midpoint, because at the midpoint I can create what? Well, not the bench. If I want the bench to be equidistant, shouldn't I find all 3 perpendicular bisectors? Because the distance from, and that would create a point of concurrency or a circumcenter. So then that means that that circumcenter would be where the bench would be, and the bench would be equal distance from all the vertices of our triangle. So answer these questions here. The trees form the sides of a triangle. Find the point of concurrency of the, and they want here perpendicular bisectors of the sides. So we're just going to eyeball it. Wouldn't this be, give or take about the middle there? And I'm going to make my best judge of a perpendicular bisector. And then we're going to guess about here. Obviously we wouldn't guess if we're normally doing this. And then I'm going to make my best judge there. And then finally, here, and so this right here is where the bench is going to go. Because the distance from this tree to the bench, from this tree to the bench, and from this tree to the bench, if I drew my perpendicular bisectors correctly, would be equal distances. And so this part is asking for you to find the circumcenter of the triangle. And so we've already talked about in words how to find that, but your Common Core is really good at explaining. So we're just going to take all of that and just explain it. So the trees form a triangle. The perpendicular bisectors of that triangle form a circumcenter where the bench should be placed. that way, the bench is equidistant from each tree. So you guys are having some difficulties explaining some things on your tests. Like your last test, remember the step ladder question? You're looking at it going, well, duh, everything's equal, but you couldn't explain it. You have to get in the habit of explaining the obvious. You're like, well, that's the center between the trees, but why? So start using your math logic, triangle logic in there to try to explain where we're coming from. All right, so when you're done with that, flip. Good. Okay, so then we come to another theorem. And this one is the concurrency of the angle bisectors. So it creates a fun little item also. So let's look at the theorem first. So the theorem says that the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of the triangle. So this time, if we use the angle bisectors, the point that is created, in this case, this point right here, is kind of the reverse of the circumcenter. The circumcenter is equidistant from the vertices. This point here is equidistant from the sides. So they actually belong to the perpendicular bisectors. So those pieces are the pieces that are equal. Equal, equal, equal. Well, I can't exactly say that. They don't actually belong to the perpendicular bisectors. They just belong to the, why are these lines perpendicular from here to here? Well, this is a point and this is a line. Isn't the distance from a point to a line always a perpendicular distance? But does this actually bisect this side? Visually it doesn't look so. Definitely not here. So I take that back. In some triangles it could be. So an interesting thing occurs with this point. And this point right here is called the incenter. So the incenter is created. So you have a circumcenter and then an incenter. So the incenter is created from the angle bisectors intersection, their point of concurrency. So on here for 19, I want you to put the distance from P to X is the same as the distance from P to Y, is the same as the distance from P to Z. We're going to answer questions 20 through 22 using in-center, inscribed, and inside. So the point of concurrency of the angles bisectors of a triangle is the what? The point of concurrency. What I just call it is the incenter. So that's why we're putting incenter here. So you need to learn that. If you ask me what's an incenter, I'm going to say we should have learned what that definition means. The point of concurrency of the angle bisectors of a triangle is always inside the triangle. So unlike the circumcenter, where we just proved on this one over here that the circumcenter, the point of concurrency created by perpendicular bisectors, is it always inside the triangle? True or false here? That's on the triangle, isn't it? So it could be inside the triangle, as we noted here, but it could also be on the triangle. Whereas the incenter will always be inside the triangle. It's not going to be on the triangle. It always has to be inside the triangle. Bailey. And then an interesting occurs. I can take, since each of these pieces are equal, you can consider them a radius, and couldn't I create or inscribe a circle inside that triangle, where these would be the equal radii? And so that's what they've done here. And so the circle is inscribed in triangle ABC. Then we're not going to look at this piece here, but we're just going to observe this here and answer the question. So it says, what does QN with no notation mean? The measure or the distance from Q to N. So the distance from Q to N is 5x plus 36. Well, here's Q to N. Q to N right here. And it says the distance from Q to M, this distance here, is 2x plus 51. What is the distance from Q to O? So we want this distance, I'm going to put that in a different color, this distance from here to here. So what is this line right here doing? What's this line right here to the triangle? It's an angle bisector. What's this line right here? A bisector. Are these perpendicular bisectors, or are they just distances from the point to the side of the triangle? Look at the side here. Is this bisecting this side? This one right here? Visually, does it look like it is? Yes or no? No. So these are not perpendicular bisectors. They're just distances that Q is from the sides of the triangle. Okay? So all three of those are perpendicular to the triangle. If this is an angle bisector and that's an angle bisector, and what happens if I created an angle bisector over here? Doesn't it meet in the same point? So what can you conclude about these three lines? They're congruent, because that is the in-center. Now you were already told that these are equal, so can't I take Qn and set it exactly equal? Oh, well, we weren't told that. Qn and set it exactly equal to Qn. I can make a guess that those are equal based on the fact that, or an educated guess based on the fact that Q is the in-center. So you might want to put here Q is the in-center of triangle JKL. So they said that QM was 5x plus 36, and QM is 2x plus 51. So you solve that for x, please, on your own. You solve it. Share your answer with those around you. Share your answer with those around you. I don't hear everybody sharing. Share, share, share. All right, and then I also want you to talk with each other and see, is that the answer to the question? If the answer is no, find the answer to the question. All right, so what is the value of x? 5. Very good. And this got a lot of you on your last test also. The value of x is 5, but the question is asking what is the distance from Q to O? Well, on a multiple choice test, won't that be one of the answer choices? It was, and you got caught. You did the problem all correct, but you didn't answer the question correctly, you get no credit on that multiple choice question. So you got to be aware of that. So always be cognizant of what you're solving for. So how do I solve for QO when I don't know its value? if Q is the concurrency, then all three of those pieces are equal. Can't I use either one of these? It doesn't. Which one looks nicer to use? I'd rather use this one. Your textbook here uses this one. But I'm going to prove to you it doesn't matter which one we use. So if I use 5x plus 36 for QO, or QO could equal 2x plus 51. So we're going to use either one. So I'm plugging in there this value of 5 that we just got. So on this one I get 25 plus 36, and on this one I get 10 plus 51. This one gives me 61. Does this one give me 61 also?
Yeah.
It does. So Q to O is equal to 61. All right, so flip that. So 25 wants you to draw an inscribed circle in the diagram to the right. Inscribed, in means inside the triangle. So you wouldn't draw it outside the triangle, so we're going to draw it inside the triangle. I see already 3 distances from Q to the sides of the triangle. We're going to use those as the radii, and I can see that that's an angle bisector and that's an angle bisector. So if I draw this from here to here, that's going to meet up and be the third angle bisector. And so there's my circle inscribed inside that triangle. I did a pretty good job. All right, so then blank and blank are 2 segments that have the same length as Q to O. So what are they looking for? What are they looking for? What other 2 segments have the same length as Q to O? Yeah, so Q to N and Q to M. And in the directions above it says, is it possible for QP to equal 50? QP is right here. Is it possible for that to equal 50? Well, let's look at the relationship between QO, and QP. So is QO less than QP? Is it equal to? Is it greater than? Well, look at the circle that we drew in here. The circle that we drew in here, from here to here is the radius of the circle, right? From here to here is that same distance, radius, right? So what would you say about QP in relation to QO? Just by drawing that circle and triangle. Yeah, this is greater than this one. So QP, if I read this backwards, is greater than QO. So this one would be wrong, because this one is saying QO, if you read it this way, is greater than QP. So we want this one. So given our answer to question 27, is it possible for QP to equal 50? Well, aren't they using the same triangle that we had over here? They don't really tell you, but we're using that same triangle. So we know that the distance from Q to O is 61. So since the distance of Q to O is 61, is it possible for Q to P to be 50? No. So since the distance of Q to O is 61, Q to P must be larger, so it cannot equal 50. Just by drawing that circle in the triangle, we were able to make that comparison. All right, last thing is our lesson check. So I want you to answer questions 29 through 31 on your own. Some of it is a review. the last question is interesting. Use your triangles above to try to figure it out. And then I want you to discuss with those around you what you feel the answer is. All right, so what did you conclude about the circumcenter on a triangle? Which type of triangle is the circumcenter outside the triangle? Is it outside the acute, the obtuse, or the right? What do you think? Did you draw your perpendicular bisectors to determine it? You can't determine it if you don't draw it. We already know where it occurs on the right triangle, don't we? On the right triangle, most specifically on the hypotenuse. So it can't be the right triangle. So you need to determine, and if you look back at this example, what kind of a triangle is that example there? Oh wait, that's the wrong one. What kind of a triangle is that example right there? Acute or obtuse? Acute. Where is the circumcenter in that one? On the inside. So that leaves us only what triangle? The obtuse. So if you look at the three triangles, if you drew them correctly, here's my three triangles. I've drawn the perpendicular bisectors to all three triangles. So on the acute triangle, the circumcenter is inside. On the obtuse triangle, that's where it's outside. And on the right triangle, that's where it's on the triangle. You need to know those because that's a very popular question to be asked. So if I were you, I would write here that acute right here is inside, and on the right it's on, most specifically the hypotenuse. And so the answer is the obtuse, that it's outside. So the one that they're looking for is that one right there. And make sure you have those pictures to show it. Any questions on that? Okay.